So the ways that we've talked about measuring concentrations for a solution are molarity, which is the most popular way, molality, which we saw in the freezing point depression and the boiling point elevation, mass percent, which we saw that was used in lowering the vapor pressure of a solution as compared to pure water. And then, of course, mole fraction, where we take the mole solute divided by the moles of solution. There is another term that's more used in industry and biology, and that is parts per million or parts per billion. And they might mention it on your final Utah test, and so I just want to mention it here, even though you won't have any problems. So parts per million and parts per billion are used for usually contaminants in the environment or to represent some sort of pollution. And it is a very, very small amount, and it's kind of like mass percent, but instead of multiplying by 100, you end up multiplying by a million for parts per million or a billion for parts per billion. If you look right here, parts per million, grams solute divided by grams of your solution. So that's your mass percent. And if I multiply it by a million, then this would be my parts per million. So again, these are for really, really, really small concentrations. I took this picture just at the gas pump, and you can see that the sulfur contaminant in the diesel fuel, it is 15 parts per million maximum. So it's not to go over that. Another example of this unit is in contaminants in our food supply. So in our food supply, especially grains, it's really hard to keep the rodent droppings or the insect parts out of our food. So I know that sounds really disgusting, but it's just a fact of life. So the stomach acid will kill it, right? So the USDA level allows for 5 parts per million rat droppings in cereals. So the rodents and the rats, they just get into our grain supply and you just can't get it out. And so it actually ends up being ground up into the flour and made into products that we consume every day. So just as a little exercise in parts per million, if we take that 5 parts per million and we actually figure out how many grams of rodent scat is in a box of cold cereal, we could calculate and solve for how many grams, and we would get a really, really, really small amount in that one box of cereal. So again, parts per million are used, and parts per billion are used for really, really small amounts. Here's another diagram. This is measuring the contamination of mercury in fish. So when you look at fish, small fish eat even smaller fish, and then they are eaten by bigger fish, which are eaten by even bigger fish. So it's called biomagnification. And with mercury, once it gets into an animal's tissues, there's no way to get it out. So the krill, the really, really small organisms that the small fish eat, they have it, and then the small fish concentrate it in their tissues, and it passes on till you get to the very, very large fishes. So right here, these are some of the large fish that have really high mercury concentrations. And so it's advised that you either not eat these fish or you eat them really sparingly. So especially if you are a pregnant mother or you're a small growing child, I consider teenagers a part of that, you should really limit your eating of these types of fish. And I did put tuna here because for a lot of Utahns, this is where we get our fish because we're so far inland. So for tuna fish recommendation, only have a tuna fish sandwich maybe once a week. Okay, and if you are again, if you have somebody you know that is pregnant, they should really limit how much tuna they have because they do not want to pass on that mercury contamination on to their unborn baby. Mercury poisoning is a real thing. It affects developing brains. It causes learning difficulties, and it's just something that you want to avoid.